So I can zoom in here just by scrolling in, so I can get it very accurate if I wanted to. So move it up just exactly, and I can scroll back out, grab it and move it, and scroll to the bottom here. Zoom in and make sure I'm right at the bottom if I want. Okay, and then I'm going to set my distance for my scale. So if I say that that is, let's say that was 80 centimeters, 0.8, I want to put it in meters. Now it converts my whole video into meters. Okay, so I got to put that here. So that's the length of 0.8. Now I'm going to go and I only want to track it once it's moving. Once it's off of this person's hand, I want it actually undergoing just by gravity itself. So I'm going to go ahead and I'm going to figure out, I'm going to scroll forward in the video until I see that it's been released. And that first moment that it's been released. So right there, I can see that the person's not touching it anymore. And I'm going to drag the bottom, this little arrow at the bottom, to say that that is my time 0. Right there. The other thing I'm going to do is I'm going to set my axis. I can grab this axis and I'm going to put it to where the front wheel of it, that's going to be my 0 in the Y. And I'm going to rotate my axis by just grabbing one of the arms of the axis, and I can rotate it so that it is, the x-axis is parallel to my ramp. Yeah?
You're supposed to put at the center of the car.
I'm putting it at the front wheel because that's where I'm going to be tracking. I'm going to track the front wheel every time.
Academy now, please. All senior boys rugby to the Spartan Academy now, please.
Okay, so I can go ahead and do that. So now I'm going to click the mass A, and then I'm going to start to track it. So I'm going to hit Shift, click, and I'm going to click my first spot right at that axis, right at the intersection, and that should give me my 0, 0. So it's pretty close to 0, 0. It's 0.003 in the x, and 0.001 in the y. That's pretty much 0, 0. And then it's, every time I click, it shifts the frame. So this is where I clicked the first time. It shifts, sorry, here. It's going to shift the frame up, advance the frame by 1. So I'm going to go ahead and click it again. I'm going to click always on the x-axis, and every time it's going to click, I'm going to click the front of the tire here, and it is going to track that front of the tire all the way through. I could zoom in for every time I click. For time-wise, I'm not going to do that today, but you could by scrolling in. So here I'm going here, I'm clicking on the front tire. It's a little blurry, so that's why I'm always trying to track the same thing every time. So you can see here that I'm getting a curve. You can see that pretty clearly. That's probably enough data. That's probably my last piece of data right here, and that's it. So I have all my data. That's as simple as it is, right? That's all my data. That's giving me position in the x and position in the y. I don't care, sorry, position in the x versus time. I don't care about the y. The y is the vertical, it doesn't matter, right? So in the Newton's second law lab, you're going to only be tracking the horizontal, the car going across the track there. So once I have that, I'm going to open up Excel. You could use Calc or spreadsheet from Google Docs. Shouldn't really matter. It's very similar programs. And I'm going to go back. So I opened up a new workbook in Excel. I'm going to minimize that. I'm going to grab this data here. So I'm going to click on it, and I'm going to highlight the X and the time. So the position in the X, and the position and the time, and I'm going to copy it. Copy selected data. So I just right-clicked on the selection. And I'm going to say full precision. I want to copy the full precision, so all the data points on that. Go back to my Excel, and I'm going to hit paste.
When I say full what?
Full precision. So I'll zoom in so you can see a little bit better what I did. And I don't like it in scientific notation. That's really unnecessary. So I'm going to scroll and grab all of this data. And I can change the data. Right now, you can see that it says number is scientific. I want to make it a number. There it is, it's a number. I can change the number of decimal points as well. Right here it says increase or decrease the number of decimal places. So I could decrease it like that to one significant digit, or I could increase it to as many significant digits as I saw fit.
What would you prefer?
Well, for me, you'd have to ask yourself, what do you think the computer would be accurate in tracking? How close could they track it? To the nearest millimeter, maybe? Or to the nearest centimeter? You have to decide that. So I'm going to do mine, this is right now, to the nearest millimeter, right? Because it's 3 significant digits, so this would be tenths, hundredths, thousandths, right? So that would be the nearest thousandths of a meter, and so that would be a millimeter, right? So I can track it to that. I'm going to show you how to graph. That's probably the most important thing now to do. I'm going to go to charts. Now, Excel seems to change all the time. They change where the menus are and how the menus look. I haven't really used this version very much. I've just kind of, in these types of programs, you kind of just got to play around. And I'm kind of self-taught in Excel. I know quite a bit in Excel now, but just go to charts, and I want an XY scatter plot. I want it to look like that. I don't want a line, so I'm going to just want the dots. And there's an XY scatter plot, and it anticipated what I wanted to do, time and X. If I didn't have that, let's say I didn't highlight that, I just deleted the graph, I can go right into my plot and go XY plot, and it just comes up with a blank one. I'm going to show you how to select the data that you want.
The other graph, was it velocity time graph?
No, that was position time. But it's because I selected the data. I usually like to select my own data to make sure that I have it in the proper way. So I'm going to right click and I'm going to go select data. So I'm just right clicking on this chart area, select data. And you add a series, meaning I'm adding a graph onto it. A series kind of means a series of X and Y values. I can name that series, I could call it trial 1. So if I had actually many different trials, which we do, I could put it all on one graph if I wanted to. It'd be really messy. I'd recommend that you do 5 different position time graphs. But this is going to make it so much easier. Watch this. I'm going to select my X values. Which one should be X? Time or position?
Position. No, wait, time.
Time is independent. Position depends on the time. So I'm going to select it. Sorry? I'm going to select all my time values right there. I just selected it, I just dragged it down. Click back here, and it tells you on the sheet, it says it's on sheet 1, and it tells you the rows. It says column. So Excel's split up into columns, A, B, C, D, E, F, G, all the way, and rows in numbers. So it tells you the addresses that it took it from. It took it from A3 to A28. So I know I've got the right data, and actually you can see that it's kind of blinking. It shows me the data. I'm going to select my Y values. I want the position values. So I want from B3 to B28. So I'm just going to drag it down and select that data. And there I have the data, and I'm going to hit OK. So there is my graph, right there. I don't like the way it looks. You probably don't like the way it looks either. So I'm going to change the way it looks. The first thing I'm going to do is I'm going to go to, I think it's in chart layout. I'm going to add some titles. So I'm going to go to the chart title. I want the title above the chart, and I'm going to go and I'm going to edit it. I'm going to say that this is going to be, this is trial 1. Oops. Position versus time. I want some axis titles too. So I'm going to go to axis titles, and I want a vertical axis title, and I do want to rotate the title. So there it is. And I can go, I know that this is position in meters, and the direction is down the ramp. There it is. There's my Y title. I can make my X title now. Sorry, my X-axis title. So go to, again, to axis titles, and go to horizontal title. title below the axis. And I want this to be saying time in seconds. So you should always in your labels put the units and the direction. Well, there's no direction for time. Yeah?
Okay, so are we able to copy paste these graphs into like a Word document?
Absolutely. I'm going to do that last. Watch this. So I'm going to delete the trial. I don't like this right now because it would be hard for me to do tangents. Wouldn't you agree? To pick off the points. So I'm going to go to this axis. I'm going to right click on it. I'm going to say add minor grid lines. Let's start with major grid lines. These are major grid lines. That's not good enough for me. I'm still not very defined in it. So I'm going to add minor grid lines. And now you can see. I can do the same on the Y. Go to add minor grid lines. And now you can see that I have really nice ability to pick off my points and where these points lie. Okay? I think you can also change these points, the shape of it.
Yeah, it's too big.
Right? It's too big,
Yeah.
so format data series, maybe? No, format data labels, I would think. No, I don't want the, oh, it gives you actually the data. So you can actually see the data. So I'm going to take off that, but you could pick off the, I want to get those off. Oops. Yeah, there it is. Don't want the Y value. I'm going to take that off, but I think I can change the, I know you can definitely change the shape of it, and I just have to kind of play around to figure out how to do that. Let's see. Well, before I do this, let's go to add trend line. I can add a trend line. What type of equation do you think it is? Think about your uniform acceleration equation. What type of equations are those? Delta D equals VI delta T equals 1/2 A delta T squared. What type of formula is that? What type of equation is that? You learned it in math. It's got a squared term in it. It's quadratic. So I can go to a polynomial and say it's the order of 2. I can even go and say, in options, give me the equation and the r squared value. And it just gave me the quadratic equation for my curve. And it made its own line of best fit. Right there. And as the closer it is, this r squared value, the closer it is to 1, it means the closer my data fits this equation. Right? So if it was an r squared of 0.5, it doesn't fit it very well. Right? So the closer it is to 1, that's very close to 1. So my data is very quadratic. Right? And it should be. Think about, those uniform acceleration equations, because it has a delta t squared in it, that would be your x squared term. This is a quadratic equation. Right? So that's important to understand. I wouldn't use this equation, you don't really need it, and I would probably draw this line by hand, this trend line, but it's a nice feature that you know it's there. The last thing that I want to, someone wanted to know, can I put this into Word? Yeah, I can. And you would probably be able to do that, and I don't know what the equivalent for calc is for Word. What is that? Does anyone know the equivalent program for that's the Sun programs?
Open
Office.
Yeah.
Open Office Word. I don't know.
Calc?
No, calc is for the same as Excel. Writer? Okay. So I can say,
Oh, yeah.
you know, I am writing a laboratory report for SPH3U, blah, 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 whatever. And then I want to talk about this graph below. And obviously you could say based on, you know, the trend of figure 1 below. And you can go and hit and go back to Excel. And you can copy this. Copy. I just right-clicked on the graph. Copy. Go into Word. Paste. Control V. Paste. And there it is.
Swig.
Right? If I wanted to make my graph, I could insert a break here. Insert break. Next page. And I could change this page to be landscape and make it very big. I like my graphs, especially for position time graphs, I like them to be the full page so I can make my tangents really nicely. I can make it the full page. Let's go down a little bit. So like that. You can see it's nice and big now. And so you can draw your tangents on this very nicely. Does that make sense to people?
Do you draw them with a pencil? Or?
Yeah, you would draw them. I would do them with, you could do it in pencil or colored pens to help you differentiate, to communicate well. It's up to you on how you want to do it, yeah?
For this lab, will we have to convert this graph into velocity, time, and
Yes.
Oh, okay. But
You'll need 15 graphs.
15 graphs. And I also had one more question.
Technically, you could be done at velocity time. You wouldn't have to give acceleration times. Because once
So
you find
10?
the slope of the velocity time graph, I will give you guys, I'm actually going to give you guys a document tomorrow that's going to specify what I want to see. Okay, so I'm going to outline what I'm looking for, what graphs I'm looking for, where the marks are allocated,